Hello, mathletes. Dave Staublin here, and we're going to learn about arc length. Now, I've got a circle drawn in here, and it has radius r and angle theta, and we are going to use those two pieces of information to find that length along the arc. That's called the arc length. Now, believe it or not, arc length is represented by the letter S. It makes no sense to me. You would think that it would be A or something like that. But the arc length is represented by letter S. And the formula is the radius times the angle. There's only one trick, that the angle must be in radians. Degrees not allowed. It does not work if it's degrees. So if the angle is in degrees, you got to convert it to radians, because this only works if the angle is in radians. All right, let's do an example here. Let's say, for example, we have a circle and the radius is 15 inches and the angle is 2 pi over 3 radians. This is not really to scale, it'd be more like that. And we want to find that arc length. So it would be the radius, which is 15 inches, times the angle, which is 2 pi over 3 radians. And because we're doing an arc length, typically we don't leave the pi, but we multiply it out. And so in this case, we would do 15 times 2 times pi divided by 3. And we'd get about 31.4 inches. Okay, let's do one more example, and let's say that the radius is, I don't know, we'll say it's 5, and then let's say that our angle is 75 degrees, and we want to find that arc length. So S equals the radius, which is 5. Let's make that centimeters. And then the angle is 75 degrees, but we know it has to be in radians, so you got to do the conversion. 180 degrees is pi radians, and so the degrees cancel out. And all we have to do now is multiply it out. So 5 times 75 times pi divided by 180. And it comes out 6.5 approximately, and our units are centimeters. Now, radians technically are considered unitless, so you don't have to write the radian on there. Just that unit right there. Okay, that's it.